graph of the function f of x is equal to -2 sine pi over 4x plus 3. Okay. One quick note here, because this is a -2 in the front here, this is going to be reflected across the x-axis. So just so that we get an image, you know, like a regular sine, real quickly, just I won't draw it in here, but like the regular sine goes to a hill down to a valley with 0 in the middle, and it's 0 starting and 0 ending. So if this negative sign right here is going to flip this graph upside down, so across, it's going to mirror it across the x-axis. So that means that it's going to look like this, and then it's going to look like that, you know, so that what used to be a hill is now going to look like a valley, and what used to be your valley is now going to be a hill. So that's what this negative sign in front is going to do to our graph. So most importantly for us for right now, we're going to just make note that at start, this function is going to be the height, and I'm going to list the height of the function at the 4 or 5 actually crucial areas. So we're looking at the red graph. At start, the height of the function is still 0. Then at a fourth of the way through, it's going to hit, so right here, it's going to hit a min value. Then halfway through, it's back at 0, and fourth of the way through, it's going to be at max. 3/4 of the way through, it's at max. And then at the ending, notice the red one is back at 0. What I'm talking about is that the height of the function at those important locations, okay? So that's what's going to happen because it's negative and because it's a sine function. Okay, next. We do notice that we have a +3 on the outside. Here's your parentheses. So everything within the parentheses that come right after the word sine are called the argument of the sine function. And what goes on in there affects your x values. But what goes on outside these parentheses, so this stuff, that's going to affect the x values, the x-axis.
Turning the microwave on, there's going to be noise.
Okay, excuse me, sorry about that. Okay, so this number right here that is going on outside of those parentheses, that is going to be affecting the y-axis. That means the the y coordinates. So for us, our graph is going to be lifted up 3 spaces because it's +3. So we're looking at a regular sine graph, and it should be pushed up 3. And this 2 in the front means that the min and max values are going to, instead of being at 1 and -1, as in a basic sine graph, they're going to be multiplied by this 2, but then they're also going to be then you would add this 3 as well to find the final y value. But what we can do is we're going to be graphing this line, because this will be the midline. This number is the midline of the graph. It's going to cut our graph in half horizontally at 3 right there. Okay, then our max and min values, because this is a 2, this amplitude is called, the amplitude is 2. That means the distance from our midline to the max value is going to be 2. So like I said, we're going to start and we're going to it's going to go down and then come back up, and then so just go to a hill to a valley. But the min value there is going to be 2 below this midline, and then the max value is going to be 2 above the midline. So we can write that in now. So 2 below would be at 1, and 2 above would be at 5. So those will be our min and max values. This is height of regular sine x, kind of, and then this is be our height of the 2 sine x plus 5. You know, simplified version like that. Okay, one more thing that we have to go over, and the 0 of 3. Why did I say plus 5? Plus 3. Okay, so the 0 is going to happen at 3. And there we go. Okay. Now there's one more thing that we have to go over, and that is that we're multiplying within the argument like that right there. So that means it's going to change our x values. So we need to find the period. The period is where it goes through one full cycle before it starts repeating itself again. I guess the distance along the x-axis where it goes through one full cycle before it repeats itself again. So the period is 2 pi, because this is a sine function, is 2 pi over b. B is here is the coefficient on this argument and the variable, and it is pi over 4. So we have to remember carefully how we divide fractions like this. And this is the larger fraction bar, so it means 2 pi divided by pi over 4. So I keep flip change, or KFC, so I keep the first fraction the same. I flip the second one, which is 4 over pi, and then I change the division to multiplication. Now the pi's are going to cancel since I have one. We can divide by pi on top and bottom there. And then I get 2 times 4, which is 8. So our period is 8. So that means between 0 and 8, that's where we're going to have this, the full cycle. So halfway through would be at 4, and a quarter of the way through would be at 2, and the at 6 is 3/4 of the way through. Those are our crucial points that we must graph. So we already have it set up. At start, we're going to be at 3. So the graph is going to be at 0 on the x-axis. You're going to be at, at 3 on the y-axis. Okay, and then at 1/4 of the way through, which is right here, you're going to be at 1, because you're down 2, because you went down 2 because that coefficient was 2. And then halfway through is going to be at 3, back at 3. And then 3/4 of the way through, it's at 5. And then all the way back to 8, we're at 0 again, or the new 0. I call it the new 0, 3. Okay, and so this is our graph. It's going to look like this. And we can continue this on. You would just do another 8 on this side, and you would say, okay, well, it's going to do but it would, except for it would actually hit -1. So it looked like that, somewhat like that. There you go. All right, let's think about how we would actually communicate this to the computer, because that's a whole other issue that's hard to really work out. So notice that it gives you 2 different options down there. It says you can choose the first point being the min value, and the second point being a max value that followed by the next consecutive max value. That's one way. So you could give the computer, if you choose this method, then what you would want to do is you would want to give the computer this value and that value. And once you gave the computer those two values, then it would know what graph you're talking about. Okay, if okay, I was trying to okay, yeah, there we go. If you chose this value, this is a quarter of the way, I believe. So this is between any 0 and the next max or min. So it's like you would have to give it like, you could give it this value and this value. So let's try inputting. I kind of prefer the first one. So let's just do this one, the first one. And I wanted to do a point at 2 and 1. So there. And my next point, I don't even remember where it was. It had to be 8, right? It had to be okay, I think that's what we want. Okay. I should have done, let me just double check it. So the 2 points that we have here are located, and I wanted to give it was 2, 1. So let me write that down. And the second one was 6, 5. 2, 1, and 6, 5. So let's just look. 2, 1, and 6, 5. So that looks like it's correct. So then we would just put submit. And it likes it. Okay. Then the next way to submit this, let me clear everything, is to input the points 4 over 3f, 4, 3, and 6, 5. So 4, 3. So now I'm going to choose the other option, 4, 3, and 6, 5. And then press submit. But notice no matter which one you do, it creates the same exact graph. It's just two ways of communicating with the computer what graph you're talking about, but both of them work. All right, I hope you found this valuable. Have a great day. Bye-bye.